you look at a group of people, you can think of there being a relation between height and age. People generally get taller as they age, then remain same height for a while, and at some point they start getting a bit smaller. This is a relation because if you input age, people of same age have different heights. At any given point of age, that person will be exactly one height. It is impossible for one person to be at 6 feet and 5 feet at the same time. Consider another case. If you look at one particular location at any moment, the thermometer at that location reads one temperature. We can discern a link between time and temperature. In both cases, do you observe something? Yes, they speak about relations. Relations that happens in our daily life. In the first example, relation is between height and age of the people, while the second example was highlighting the relation between time and temperature of a particular location. Though we speak about various relations that happens around us, they all are non-mathematical, right? Relations in real life provides us with a link between any two entities. Let's now give a mathematical approach to the relations. And in this video, we are going to discuss how relations are developed in sets. The very first thing to understand is that relation is a subset of Cartesian product of two sets. Here is a diagram. Cartesian product of sets. Within that, relation comes. Alright? Let A and B are two known empty sets where A cross B is a set of ordered pairs and a relation is derived by stating the relationship between the first element and the second element of the ordered pair of A cross B. The second element is called the image of the first element. Relations are usually shown using arrow diagrams, which we will discuss later. Now, let's discuss important terminologies used in relations. The first one is domain, the second is range, and the third is codomain. Let's see one by one. The set of all primary elements of the ordered pairs in a relation from set A to set B is called the domain of the relation. Let's see the representation of the domain in set builder form, which is given by domain of R is equal to A such that A comma B is an element of a real number. Next, while the set of all second elements of the ordered pairs in a relation from set A to set B is called the range of the relation. Let's see the representation of the range. The set builder form is given by range R is equal to B such that A comma B is an element of real number. Now, what is codomain of the relation? In set theory, set B as a whole is called the codomain of the relation. Now, when we closely observe, range is a subset of the codomain. Here is the diagram. Codomain, within that, the range comes. Okay? Now, let's see one example for better understanding. If set A is equal to 1, 2, 3, 4, 5 and the set B is given by set 1, 2, 3, 4, 5, 6, 7, 8, 9 and the relation is described as follows. R is equal to A comma B such that 2A is equal to B, where A is an element of set A and B is an element of set B. Determine the range, domain and codomain of the relation. We are provided with a relation from set A to set B such that the second element is the twice of the first element. First, we make a table to get a better idea showing the values of A and B. Alright? So when A is equal to 1, B, what is B? B is equal to 2. We get the ordered pair as 1, 2. Now when A equal to 2, B equal to 4. What is the ordered pair AB? It is 2, 4. Now when A equal to 3, B equal to 6. We get the A, B as 3, 6. Now when A equal to 4, B equal to 8. We get A, B as 4, 8. Why 5 is not taken? Because 2 into 5 makes 10, which is not there in our set B. Alright? So, the relation is given by R is equal to set ordered pair 1, 2, ordered pair 2, 4, ordered pair 3, 6 and the ordered pair 4, 8. Now, coming to the second part of the question, what is the domain, range and codomain? Domain is given by set of all first elements in the set R. That is given by set 1, 2, 3, 4. Now, what is the range? Range is given by the set of all second elements in the set R, which is given by 2, 4, 6 and 8. Now, what is the codomain? Codomain is your set B and that is given by set 1 to 9. Alright. Now, a visual representation of the relation is shown using an arrow diagram. First, set A elements with 1 to 5 is given. Now, set B elements from 1 to 9 appears. Now, the mapping is done from 1 to 2, then 2 to 4, then from 3 to 6 and from 4 to 8. Note that the elements 1, 3, 5, 7 and 9 is not related to any element in set A. So, we have learned what are relations, its important terminologies and the visual representation. Next, we will see how many relations can be defined for the given two sets. Alright? The total number of relations is nothing but the number of possible subsets of A cross B. That is, if n of A is equal to P, n of B is equal to Q, n of A cross B is given by P into Q, then the total number of relations is given by the equation 2 raised to 2 PQ. Let's see one example for better understanding. Set L represents the set of letters in the word max. So, your set L will be M, A, T, H and S. Now, set V represents the set of vowels in the word max. So, it contains only the letter A. Alright. Now, N of L. What is N of L? N of L is equal to 5. The number of elements in L. Now, N of V is equal to 1. Now, N of L cross V is equal to 5 into 1, which is nothing but 5. Now, the total number of relations is given by 2 raised to 2, 5, which is 32. Learning relations in sets helps to solve the real-life problems at the application level. But certain relations will qualify to be functions. Let's see what they are in the coming video. Now, let's summarize what we have learned in this session.
Manorama Horizon. Learning made simple.